Here are some quick and easy examples to help you if you're struggling with your homework or your notes on similar polygons. Similar figures look alike, but one is a smaller version than the other. So if you're going to draw a ship, you're not going to draw the exact size of the real ship. This is what architects do when they make scale drawings for models of buildings or other things that they plan on creating. So just like congruent polygons, corresponding angles must be congruent. So each pair of angles in the larger figure and the smaller figure will have equal measurements. For example, here are some given angle measures for the polygons that you see below. So if angle A is 80 degrees, then the corresponding angle would be W, so they are congruent, so W is 80. Angle B in the larger polygon corresponds to angle X in the smaller, so if angle B is 30, angle X is 30. And finally, angle D would be corresponding to angle Z, so if angle Z is 170, angle D would also be 170. Now, unlike congruent figures, where all the sides must be the same, in similar figures, the sides are a little different. They have to be proportional. So we write an extended proportion, similar to an extended ratio, that shows all the pairs of corresponding sides. So side AB corresponds with side WX, side BC corresponds with side XY, side CD would correspond with side YZ, and DA corresponds with ZW. What that means is you should be able to multiply each side of the smaller polygon by the same number and get its corresponding side on the bigger polygon. And this is similar to the extended ratio problems that we were doing in section 7.1. So if the smaller side of the polygon is 4, if I multiply by 2, the larger polygon side would be 8. And I would do that for each of the 4 sides. So my smaller polygon had sides of 2, 3, 4, and 5. I chose to double every side, so the sides of the larger polygon are still in proportion, and they're 4, 6, 8, and 10. In the previous chapter, you had experience writing congruence statements, and now we write what's called a similarity statement. So that says if corresponding angles are congruent and the sides are proportional, then we say that two figures are similar. So instead of the equal sign here, we just simply have that wavy sign. This means is similar to. So we state that polygon ABCD is similar to polygon WXYZ. In the previous example, we took the sides of the smaller polygon and multiplied by 2 to get the sides of the larger polygon. And that's called a scale factor. And that can be represented as a ratio of corresponding sides. And you can compare them as the smaller side to the big side or the big side to the small side. Remember, in a ratio, the order that you're asked to write things matters. So when it says what is the scale factor of the large polygon to the small, we take one side of the large polygon, for example 10, and we match it up with the corresponding side on the smaller polygon, which would be 4. And then you can simplify that ratio. So the scale factor from the large polygon to the small is 5/2. And you can use that to find missing side lengths. So we are going to use the ratio of 5:2 to set up proportions so that we can solve for the missing sides x, y, and z. So to start with, we'll do side z. So 5/2 would equal 6/z. We cross multiply, and it turns out that z equals 2.4. So you can get a decimal, so don't be surprised when you're doing problems if you do. When you're solving for x, again, we use that same scale factor, 5/2 equals x/7, so make sure you pick the corresponding sides. We cross multiply, and we get x would be 17.5. And finally, solving for y, again, we use the scale factor, corresponding sides of 8 and y, cross multiply, and y equals 3.2. So there you have just some really quick examples that will help you with your homework problems and solving proportions by using scale factor.